So today we will discuss more about 8086 microprocessor. As you have studied, 8086 is the first 16-bit microprocessor by Intel Corporation. And what is a microprocessor? It is true CPU on a chip. So let us check the features of 8086 at a glance. So it is constructed using HMOS technology. Hope you remember high density metal oxide semiconductor technology. And do you know how many transistors it consists of? 29,000 transistors are present in 8086. And as you can see, it is a dual in package. And it requires a 5-volt power supply for the working. And it operates at 5 megahertz internal clock frequency. So in order to generate the 5 megahertz clock frequency for its operation, an external clock generator or driver chip will generate this input signal. And the signal generated by chip is given to 8086, which will be again internally divided by 3. How much frequency of frequency of clock must be generated by external clock generator so that 8086 can operate at 5 megahertz. How much it would be? 5 into 3, that means 15 megahertz of clock frequency must be produced by the external clock generator. And in this case, external clock generator or driver chip is 8284, okay, which is connected to the clock pin of 8086, which generates 15 megahertz, which will be divided internally by 3, and hence 8086 will be operating at 5 megahertz. And it has a 20-bit address lines, and hence it has a memory of about 2 into 2 raised to 20. Okay, that is, if you have a 1 bit, it can be called out as 0 and 1, isn't it? So if therefore for a single bit you have two possibility, either 0 or 1. So for 20 bits it would have 2 raised to 20 way of addressing things. Okay, so 2 raised to 20 is equivalent to 1 megabyte. Okay, so 8086 has a memory space of 1 megabyte. How do you get it? It is the number of bits available for addressing will constitute such a memory. And it uses segmented memory. The memory will be divided into different segments, and it can prefetch up to 6 instruction bytes from memory and queue them. Okay, so when the execution is going on, the next 6 instructions will be fetched from memory and keep it in ready or queue, so that soon after the execution of the current instruction, there is no delay in fetching the byte. So it will speed up the execution. And memory is usually organized as byte. Okay, so 1 byte, 2 byte, 3 byte, etc. up to 1 megabyte is represented using 20 bits, right? So here, instead of writing all the 20 bits, what we do is we took BCD representation. That means F stands for, what is F in hexadecimal? All the 4 bits are 1, 1, 1, 1, 1. Similarly, next F, so 1, 1, 1, 1. Similarly, third, fourth, and fifth. Okay, so 5 into 4 ones, which means 20 bits are available. And memory will be consisting of, you can think it like it is a shelf with each shelf of width 1 byte. Okay, and it is 16-bit word consists of, so if we have already mentioned that a microprocessor is designated as 16-bit because it can process a 16-bit word, or because its arithmetic and logic unit is of size 16-bit. What does that mean? It just means that a 16-bit word can be processed by such a microprocessor. Okay, so instead of representing the entire 16-bit in the memory, we have bytes for representing, right? So 16-bit means how many bytes are there? 1 byte is equal to 8 bits. So 16-bit will correspond to 2 bytes. So in 16-bit word consists of 2 consecutive bytes, which means 16-bit word അല്ലെങ്കിൽ ഒരു ഡേറ്റ 16-ബിറ്റിനെയാണ് നമ്മൾ വേർഡ് എന്ന് പറയുന്നത്. So such a data will be stored as 2 consecutive bytes, where low address byte will be carrying the low byte of the word or data, and high addressed byte will contain the high byte of the word, which means here is an example. You have in the low address, for example, take any address like 520 hexadecimal, indicating hexadecimal 16. So it will carry a data 07, and the high byte is in the next consecutive address 521, will carry a data as 26. So what would be the 16-bit data? What would be the 16-bit data? It would be 2607. What does that mean? The low portion of the byte of the data is stored in low address byte, and the high byte of the data is stored in the high address byte. Hope that is clear. So for word address, the programmer will use low order address to specify the whole 16-bit word. What does that mean? That is, the programmer need not specify both the address. The programmer will be only specifying the low order address. This alone will be specified, and this will be the data from the next location will be automatically fetched. Okay, let's see how it is done. So which means 00520 will be the only address which will be mentioned in this particular example to represent a 16-bit word. We need not mention the data in both the address. അപ്പോൾ both രണ്ട് അഡ്രസ്സും ഇൻസ്ട്രക്ഷനിൽ പറയേണ്ട ആവശ്യമില്ല. We'll be only mentioning the low order address, and based on the instruction, the system will be taking the mentioned address as well as the data from the next address. Okay. So let us see how this memory access is done. Let us consider we are going to access a 16-bit data. The 16-bit data is called word to or from memory. So so if the first byte of the word is at an even address, okay, low part of the data, if it is in even address, what is the procedure is that the system will read this 16-bit word in one operation, while if it is in odd address, then the system will read 2 memory access operations, and then it will read the data. Okay, അപ്പോൾ ഇവിടെ ഈവൻ അഡ്രസ്സിലാണെങ്കിൽ 16-ബിറ്റ് വേർഡ് ഒറ്റ ഓപ്പറേഷനിൽ തന്നെ ആക്സസ് ചെയ്യും. പക്ഷേ നമ്മുടെ വേർഡ് ഇരിക്കുന്നത് ഓഡ് അഡ്രസ്സിലാണെങ്കിൽ ദ സിസ്റ്റം വിൽ ഹാവ് ടു പെർഫോം 2 സ്റ്റെപ്സ് ആയിട്ടായിരിക്കും രണ്ട് അഡ്രസ്സും ആക്സസ് ചെയ്യാൻ പോകുന്നത്. Okay, and it will be discarding the unwanted bytes. Let us see how it is done. Let us consider an instruction move bx, address. Okay, So that means, what does that mean? ഈ അഡ്രസ്സിൽ പറഞ്ഞിരിക്കുന്ന ഡേറ്റ ഹാസ് ടു ബി മൂവ്ഡ് ടു എ രജിസ്റ്റർ BX. ആൻഡ് BX ഇസ് എ 16-bit രജിസ്റ്റർ ആണ്. അതിന് രണ്ട് പാർട്ടുണ്ട്, BH ആൻഡ് BL, which means BH means high part of the register, BL means low part of the register. ഒരു 16-bit രജിസ്റ്റർ ആണ്. അപ്പം നമ്മൾ വി ആർ ഗോയിങ് ടു so it is not mentioned it is a 16-bit transfer, right? How do you recognize it then? It is because the destination is of size 16-bit. That is how or the system realized that a 16-bit data is going to be transferred. Okay, so let's see how it is done. Let the address, for an example, be 3024, which is an even address. So what will happen? This will load the low and high byte of BX with contents of memory location. ഏതാണോ ആദ്യം പറഞ്ഞിരിക്കുന്ന ലൊക്കേഷൻ 3024, that will be loaded in BL, and 3000 and data from 3025 will be loaded in BH in a single step. Okay, let us see how it is done. So you have two memory location, 3024 and 3025. Okay, so the system will point only to the, it is pointing only to the even address. That means in the instruction only the even address is mentioned. So what will the system do? The system has realized that a 16-bit word has to be transferred. How does it realize it? Based on the destination. So now what the system will do? The system will allow the data in the low address to the low portion of the register, that is BL, and the system will allow the data in the high address to the high part of the register, which is BH. Okay, and this happens in a single access, single access this process will be done. Now let's check if it was an odd address. So instead of an even address, let the address mentioned in the instruction be an odd. Then what was the procedure we have mentioned? Yeah, we have mentioned that system will have to perform two accesses to reach to the memory locations. So how it is done? First, every time the system will point to a even address. Okay, whether in the equation, in the instruction it be represented using odd or even, the system will always point to the or fetch the even address. Okay, so what was the address given? 40,005 is the required one. So the system, instead of going to the 40,005, it will go to the 40,004, just a penultimate address in the first operation. Okay, പക്ഷേ 40,004 വേണോ? No, it is not required. So it will be discarded, and only the data from 40,005, which is mentioned in the instruction, will be transferred to BL. While in the next step, again it will do 40,006 ലേക്ക് പോകും. Along with that 40,007 എടുക്കുന്നുണ്ട്. But ഏത് മാത്രം മതി? We have already an 8-bit കയറി കഴിഞ്ഞു. So ഒരു 8-bit കൂടി കിട്ടിയാൽ മതി, which is in the next location, അല്ലേ, 6ൽ. So it will ignore the content of 40,007 and only the 40,006 will be moved to the BX. Let us have a pictorial one. So we have a pointer to 40,005. പക്ഷേ സിസ്റ്റം എപ്പോഴും എങ്ങോട്ടേ പോവുള്ളൂ? It will go to a even address. Okay, so first is fetchൽ 40,004ലേക്ക് പോയി. പക്ഷേ ആ ഡേറ്റ ആവശ്യമുണ്ടോ? ഇല്ല. It is not mentioned in the address. So ഏതാണോ മെൻഷൻ ചെയ്തിരിക്കുന്ന അഡ്രസ് 40,005, so the data in the 40,005 will be loaded into the low portion of the register, which is BL. Similarly, in the next operation, it will fetch to the next even address. What is that? 40,006. and the data is present there consecutively, and hence it will be transferred to the higher portion of the register BH, which is BH, and it has already taken the data in the next location also, but that is not required, right? So it will be discarded. So hope you have understood the memory access. Thank you.